The second example of solving inequalities is going to be a little bit more complicated than the last one. This one, as you'll notice, has an inequality where there's x to the third, x squared, the variables are of a higher degree. And so what we're going to do in this is indicated by the title here, is we're going to solve the inequality by solving a corresponding equation. But at the end, we are going to put this in interval notation. It's not just going to be a single x equals something. It's going to be a range of values, and so we've got to figure out what that's going to be. First thing I would do with this one, since it says by solving a corresponding equation, just to make this a little simpler, let's turn this, let's get rid of the inequality for now. We'll deal with that later. We're just going to make it equals. Now, it doesn't seem like much of a change, but it really is if you were to just get the solutions to this one. The whole purpose of that is going to be we're going to factor this. Now, factoring, one thing you can do is always take out the greatest common factor. So you'll notice all of these have an x. So I can take out an x and have x squared minus x minus 30. That actually turns into something that's fairly easily factorable. You might recognize that one. You might be able to see that. If you want to pause it and see if you can get it before I show it to you, go ahead. But the way that this factors is x minus 6 and x plus 5. Now that is, remember that these two numbers multiply to this. They add together to get that one, so it looks like we've got a good factorization here. Now, if we were to solve this one as is, we would then say that x is equal to 0, 6, and negative 5, because those are the three numbers that make those factors equal to 0. But we're not done there, because really what we want to do in this problem is we want to find out where this stuff is less than or equal to 0. So a different method that you probably have not seen before, this is a good one to make sure you write down, is we're going to do a number line to solve this one. It's going to be kind of an interesting method for solving this. What we're going to do with it is, you'll notice these different values, we're going to put these in order from left to right. So I'm going to start with negative 5 right here, because that's on the number line, that's more to the left. And then 0's in the middle, and 6 is on the right. And so we're going to use this as kind of a guideline. It doesn't matter that they're not evenly spaced. We're not going for that. But we got to see if numbers work here. So I'm going to be taking a few different test points. Now I'm going to take a test point and just make it the easiest one possible. I'm going to look at these different intervals. What's going to happen is that there's going to be, it's either going to work in this inequality or it's not going to work for that interval, and I'll show you what I mean. Let's say I look at this interval and I want to just choose a point that represents it. I could just choose the easiest one possible. I could say negative 6. If I pick negative 6 in this interval, what I do is I plug the negative 6 into my inequality. If I plug that in, here's what ends up happening. If I use the test point negative 6, like I've indicated up here, and I plug that into the original inequality, it ends up getting me negative 72 on this side. And so I have the statement negative 72 is less than 0. Is that true, is what we have to ask ourselves. And since that is true, I'm going to mark this interval with a yes. And I'm just going to section it off with a dotted line so we know that that stuff is a yes. Then I'm going to go to a point in here. Now I'm going to pick the easiest test point possible, so I'm going to pick negative 1 just because that's the smallest number to work with. And so down here you'll notice I picked negative 1. Now if I plug negative 1 into this formula, what ends up happening is I get 28. And since we have to, since 28 is actually greater than 0, then it doesn't work in this interval. This interval is a no. It doesn't satisfy my inequality of being less than or equal to 0, because 28 is not less than or equal to 0. I go about that same process with a couple other points. I could choose 1. Oops, I put this through that point. It really should be through this point right here. Sorry about that. So I choose now positive 1, maybe, and I put that in. Negative 30 is less than or equal to 0, so this interval works. This one's a yes. And then I do one more. And 7, if I choose 7 over here, 7, I plug it in, I get 84, which is not less than or equal to 0, and so that interval doesn't work. And the intervals that I'm looking for now, they're going to be the yeses. So I've got this interval, and I've got this interval of things that actually work in this problem. And that's the ones that I want to report in my final answer. So you'll notice here that it goes from, we've got an equal to bar, and it goes from negative infinity up through negative 5. And so I've got this region basically that's shaded in. My interval notation for that would be negative infinity to negative 5. Square bracket because it's got an equal to bar. Then over here, the yes that I want is between 0 and 6. That's just a closed interval, and so that goes from 0 to 6. And then I can put a union between those two because that's what it will look like when I combine the two into one big statement. So I know that's a lot of stuff, that number line, but just choosing test points and seeing if they satisfy this inequality will help you determine what your solution is to that inequality.